So for number 57, you get this piecewise function, and you have to find a value of c to make it continuous. So the way you do that is you set c equal to the limit as x approaches to a of the first part of the piecewise function. When you do that, you can use sum of or difference of cubes to on the top of on the numerator, and you get x minus a times the quantity of x squared plus ax plus a squared, and then you can cancel out the x minus a's, and then you can just substitute a in, and you'll get a squared plus a squared plus a squared, which is 3a squared. So c for the first problem is going to be 3a squared. And then for number 58, you have another piecewise function, and you have to find the values of a and b that will make it continuous. So the way you do that is you have to set the limits for from either of the 2 points where the function changes at 2 and 3 equal to each other, so it'll be continuous. So the way you do that is you set the limit of the first part of the piecewise function equal to the limit as x approaches 2 of the second part, and same for the second and third part, but for 3. And then after you do that, you'll get a system of equations in 2 different variables. So you'll get 4a minus 2b minus 1 equals 0, and 10a minus 4b minus 3 equals 0. And then you can use elimination, and you'll find that a is 1/2, and then b is also 1/2. And then for 59, you have another piecewise function, and you're going to try to find the value of k that makes the function continuous. So when you look at what makes the first part of the piecewise function, what the limit as x approaches 0 from both sides of the first part of the piecewise function is, if it's approaching from the positive side, then 1 over x is going to be infinity, because x is just going to be a smaller and smaller numbers, and then 1 divided by a smaller number approaches infinity. So you're going to end up with 3 plus basically 4 to the infinity plus 5 plus 4 to the infinity, and at the point 3 and 5 basically don't matter, so you're going to end up with 1. And then when you're approaching from the left hand side, from the negative side, you're going to 1 over x is going to equal 0, because it's just going to be on the bottom is going to be a smaller and smaller negative number. So you're going to end up with like 3 over 5 plus 0, and then 3 over 5. And then so since the two values of the limits from the left and the right hand side don't agree, then there's going to be no value of k that can make it continue.
Okay, and now for number 60, we're attempting to find a value that we can substitute in for this equation 2x squared minus 5x plus 3 all over x squared minus 1, that we can substitute in at 1 and negative 1 in order to make the function continuous. So first, for as x approaches 1, if we take the limit, you can first you're going to have to factor, so you're going to end up with this. You can cancel x minus 1 on top and bottom, and now you can simply substitute in x equals 1 to get negative 1/2 for x equals 1. And now for the limit as x approaches negative 1, if you want to make this continuous, it's going to have to the function is going to have to equal the limit here. So this doesn't really mean anything. So we simplified to 2x minus 3 all over x plus 1. However, this still doesn't work with x equals negative 1. So we're going to take, just to test that the limit doesn't exist, we're going to take the limit from both sides. And as you can see, this is going to equal infinity, because this is going to get closer and closer to negative 1 from the positive direction, so the denominator will still be positive, but it'll be very small. And then this one will be negative infinity for the opposite reason. So since the limit as x approaches negative 1 of f of x doesn't exist, there is no value of f of negative 1 that we can have to make the function continuous.
Alright, now on to number 80. 80 gives us the equation y equals mx cubed plus x plus a all over x cubed minus 2, and tells us that it crosses its horizontal asymptote at 6, negative 5. Since we are given that it crosses at 6, negative 5, and it's in horizontal asymptote, that means the asymptote will be at negative 5. So m would be negative 5 as the horizontal asymptote equation for same term, same degree would be m divided by whatever coefficient this is, which is 1. Now, plugging in -5 for m gives us y equals -5x cubed plus x plus a over x cubed minus 2, and we plug in the given coordinate into it, we get -5 equals -1080 plus 6 plus a, all divided by 214. Now, if we do a little bit of simplification, you'll find that a equals 4, and as this problem asks us what m plus a is equal to, we get -5 plus 4, which is -1, which would be the B in the multiple choice. And number 80 asks to find where y equals 12 is a horizontal asymptote of this equation, mx plus m times 6 to the negative x, and all divided by 4x plus 6 to the negative x. So first we're going to take the limit where x approaches infinity, and I'm going to switch around 6 to the negative x to 1 divided by 6 to the x. And that gives us this. And since 6 to the infinity turns this into an insignificant fraction, we can eliminate it and we just get mx divided by 4x, which simplifies to m over 4. And we'll simplify this, we'll use this later on, but for now let's move on to the negative infinity limit. For this, I'm just going to turn it into a limit of infinity and replace x with negative x. This will flip all the signs in here and turn this to 6 to the power of x. So we're going to divide both sides by divide by 6 to the power of x, and that will give us m and more insignificant fractions. M over 1 is equal to m, so with that in mind, we're going to plug in 12 as the asymptote, and since m divided by 4 is equal to 12, the vertical asymptote, and m is equal to 12, that means that m could equal 12 or 48. And that is all.
Okay, and now for number 82, what we want to do is sum these three limits. The limit of this function as x approaches 0 from the bottom, as it approaches 0 from the top, and as it approaches infinity. So now for these, the first two limits, they're basically the same as was presented in an earlier question. So we're just going to take the limit of 1 over x and 1 over x as it approaches 0 from below and above, and we're going to find that it equals negative infinity and positive infinity. So if we plug this in, you get 1 over 4 to the infinity, which is 0. So you have 3 plus 0 over 5 plus 0, which is 3/5. For this one, you're going to get 4 to the infinity, which is infinity. So you're going to divide top and bottom by 4 to the 1 over x, and then you'll end up with 0 plus 1 all over 0 plus 1, which is just 1. So now the limit as x approaches infinity of this, well, let's look at 1 over x again. The limit as x approaches infinity of 1 over x is simply 0. For the 0 is equal to 1 by exponent rules. So then you get 3 plus 1 over 5 plus 1, which is 4 to 6, or 2/3. And if you add these all together, 3/5 plus 2/3 plus 1, I just use my calculator for this, you'll get 34 over 15, which is answer A in the multiple choice.
Okay, alright. So this is number 80, and it shows two circles. One of them with the equation, this one over here has the equation x minus 1 squared plus y squared is equal to 1. And then another square that is centered on the origin and has a variable radius. And we're trying to find what the x-intercept of the line that intersects the intersection of the circles, the top one, and the point where the circle touches the y-axis, where that line, that x-intercept approaches. So as the circle gets smaller and smaller and smaller, right? So here we have the two equations for the circles. One of them, x squared plus y squared is equal to r squared being the radius that is variable. And then we have x minus 1 squared plus y squared is equal to 1. And then we find the x and y coordinates of the intersection between the two circles on the top here. So if we set those equations equal to each other and simplify, we get x is equal to r squared over 2. And then if we plug that into the original equation, we can find that y is equal to r root 4 minus r squared, all that divided by 2. And so by using a point slope form, we can find an equation for the line PQ, which is this line right here. And that is going to be equal to y minus r is equal to r root 4 minus r squared minus r over that over 2 minus r over r squared over 2, all that times x. This is the slope of it, slope of that line. And then since we're trying to find the x-intercept, we know that y is going to be equal to 0, so we can set that to 0, and we'll get negative r is equal to all of this. And then you kind of have to simplify this, just going through it all, and then eventually you'll get to, if you solve for x, you'll get that x is equal to root 4 minus r plus 2. So then we can take the limit of both sides. It's supposed to be limit of r as r approaches 0, not x, sorry. But you take the limit of both sides, and you can just plug in 0 to r right here. So you get root 4 minus 0, which is 2, plus 2, and that's just equal to 4. So as you can see also in this diagram here, the x-intercept of the line will approach 4.